The cosine rule. Suppose we've got a triangle ABC with angles A, B and C. Then the side lengths are small a, small b and small c, where A is the side opposite the angle A, B is the side opposite the angle B, and little c is the side opposite the angle C. Then the cosine rule states that a squared equals b squared plus c squared minus 2bc cos a. Or we can rearrange that: cos a equals b squared plus c squared minus a squared all over 2bc. Note, we use this formula in problems involving 3 sides and 1 angle in a triangle, where one of those is missing. It's worth noting that this is a version of Pythagoras' theorem when there's no right angle in the triangle. Pythagoras' theorem says that in a right angle triangle, a squared equals b squared plus c squared, whereas the cosine rule starts the same, a squared equals b squared plus c squared, but has an extra term, minus 2bc cos a, where the angle A is not a right angle. Now we can prove the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a, by first drawing an altitude CD of the triangle. In other words, drawing a perpendicular line from C to AB meeting the base at D. Now let the height of the triangle be h, and let the length AD equal x. Now AB is length C, so BD has length C minus x. Now if we look at the triangle ACD, we've got a right angle triangle, so we can use Pythagoras' theorem. B squared equals x squared plus h squared. Now that can be rearranged to give h squared equals b squared minus x squared. Now, if we look at the triangle BCD, that's a right angle triangle, so again we can use Pythagoras' theorem, and we have a squared equals c minus x all squared plus h squared, which can be rearranged as h squared equals a squared minus c minus x all squared. Now we can expand minus c minus x squared as minus c squared plus 2cx minus x squared. If we substitute h squared from equation 1 into equation 2, we have a minus c squared plus 2cx minus x squared equals b squared minus x squared. Now the minus x squareds cancel from each side of the equation, and if we add c squared and subtract 2cx from both sides, we'll end up with a squared equals c squared plus b squared minus 2cx. Now, in triangle ACD, we have the cosine of A is the adjacent over the hypotenuse. So the cosine of A is x over b, or if we multiply all the way through by b, we can write x equals b cos a. Now if we substitute the value of x in that equation into the equation 3, we get a squared equals c squared plus b squared minus 2cb cos a. Or we can write that a squared equals b squared plus c squared minus 2bc cos a. That was what we were required to prove. Now that can be rearranged fairly easily to give cos a equals b squared plus c squared minus a squared all over 2bc. Now, rather than proving the cosine rule, we can demonstrate that it's true by drawing any triangle and measuring 2 sides and an angle. So, if we look at the side AC and use a ruler, we can see that the length is about 7.6 centimetres. Now if we look at the side AB, using a ruler we can measure the line and see that the side is about 5.6 centimetres. And if we look at the angle CAB and use a protractor, we can see that the angle is about 79.8 degrees. We can see that it's slightly less than 80 degrees. Now, if we put those values into the formula for the cosine rule, we have a squared equals b squared plus c squared minus 2bc cos a. So a squared equals 7.6 squared plus 5.6 squared minus 2 times 7.6 times 5.6 cosine 79.8. And if we put that into a calculator, we get a squared is 74.0465. If we take the square root, we find a is equal to 8.605 centimetres. Now if we measure the side BC, we can see that the length seems to be about 8.6 centimetres. So the calculated answer and the measured answer both lie within the limits of our accuracy. Now let's have a look at some examples of how we can use the cosine rule to find a missing length or angle. In the first example, we want to calculate the missing side x in the above triangle. Now we're going to use the cosine rule. A squared equals b squared plus c squared minus 2bc cos a. And in the diagram we can see the side B is 4.2, the side C is 5.8, and the angle A is 63 degrees. So x squared equals 4.2 squared plus 5.8 squared minus 2 times 4.2 times 5.8 times the cosine of 63, which when we type it into a calculator gives us x squared is equal to 29.16158, and when we take the square root we get x is equal to 5.400146. So giving our answer to one decimal place, we get x is equal to 5.4 centimetres. If we look at example 2, again we've got a triangle, and in this case we want to find the angle theta, which is the angle A. Now we're going to use the cosine formula. Cos of A equals b squared plus c squared minus a squared over 2bc. This is the better form to use if you're trying to work out the angle. So the side A is 7.9, the side B is 4.9, and the side C is 4.4. So the cosine of theta is equal to 4.9 squared plus 4.4 squared minus 7.9 squared, all over 2 times 4.9 times 4.4, which is equal to minus 0.4415584. Now if we take the inverse cosine, that gives us theta is equal to the inverse cosine of minus 0.4415584, which is equal to 116.2034 degrees. So rounding it off to one decimal place, we have theta equals 116.2 degrees. Now let's look at a harder problem. Usually we use the cosine rule to find the missing angle or the side opposite the missing angle in a question involving three sides and one angle. If we want to calculate one of the other sides, we tend to use the sine rule twice. Let's look at an example. In this case we've got the triangle ABC with the angle A equal to 60 degrees. The side AB is 10 and the side BC is 9. And we're asked to find the length AC or the length x. Now x is not opposite the angle 60 degrees, so in some ways it would be better to use the sine rule. However, let's have a look at how we can do it using the cosine rule. Now the cosine rule states a squared equals b squared plus c squared minus 2bc cos a. The angle A is 60 degrees, the side A is 9. We want to calculate the length x, which is side B, and side C is 10. So if we substitute them in, we get 9 squared equals x squared plus 10 squared minus 2 times 10x cosine 60. But the cosine of 60 is 0.5. So we have 81 equals x squared plus 100 minus 20x times 0.5. And that rearranges to give x squared minus 10x plus 19 equals 0. Now that's a quadratic that doesn't factorise, so we'll need to use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1, b is minus 10, and c is 19. So if we substitute those into the formula, it simplifies to x equals 10 plus or minus the square root of 100 minus 76 all over 2, or 10 plus or minus the square root of 24 over 2, which we can work out to give as either x equals 7.44949 or x equals 2.55051. So we find there are two possible answers. AC is equal to 7.45 or AC is equal to 2.55. Now the other method would be to use the sine rule. But if we do this, we have to use the sine rule twice. First of all, we have to calculate the angle C, and then using the angles in a triangle add up to 180, we can find the angle B, and from that we can calculate the side AC or X. So to find the angle C, we'll have, using the sine rule, side C is 10, angle A is 60, and side A is 9. So sine C over 10 equals sine 60 over 9. Multiply both sides by 10. Sine C is 10 times sine 60 over 9, which works out to be 0.9622505. And if we take the inverse sine of that, we get C is 74.20683 degrees. But when we take the inverse sine, we can also have 180 minus that. So C can equal 105.7932 degrees. Also remember, A is equal to 60 degrees. Now we know the angles in a triangle add up to 180, so the angle B is equal to 180 minus A minus C. B is either 45.79 degrees or 14.207 degrees. So, using the sine rule, A over sine A equals B over sine B equals C over sine C. If we take the angle B as being 49.79 degrees, side A as 9, and the angle A being 60 degrees, we get x over the sine of 45.79 equals 9 over the sine of 60, which means x is equal to 9 times sine of 45.79 degrees over sine of 60, which works out to be 7.449. If we take B as being 14.207 degrees, then side A is equal to 9 and angle A is equal to 60 degrees. So, x over the sine of 14.207 degrees equals 9 over the sine of 60 degrees, which means x is equal to 9 times the sine of 14.207 over sine of 60, which works out to be 2.55054. And so we get AC is either equal to 7.45 or AC is equal to 2.55 centimetres, which is the same two answers as we got when we did it using the cosine rule. Remember, if you are given some other facts about the triangle, then you can select which of the two answers is the required one.